Hello everyone, welcome to the course Artificial Intelligence and Machine Learning. I'm Nandini, Assistant Professor in the Department of Information Technology at V.S.B Engineering College, Karur. So in this video, we're going to see about Unit 1, Problem Solving. So these are all the topics under problem solving. The textbook preferred for problem solving is Artificial Intelligence, a modern approach. The main objective of problem solving is study about uninformed and heuristic search techniques. The CO1, which is mapped with PO1, PO2, PO3, PO4, PO5, PO9, PO10, PO11, PO12, and PSOs of our department specific outcomes. So the main agenda for this video is search algorithm strategies, types of search algorithms, breadth first search, depth first search, uniform cost search, iterative deepening, bidirectional search, greedy first search, A-star algorithm. So the first one, that is search algorithm. So search algorithm is used to find a optimal solution to a problem by exploring a set of possible solutions. There are 6 terminologies in search algorithm. The first one is state space. The second one is start and then goal. The third one is path cast. The fourth one is search tree. The fifth one is actions and then transactions. The sixth one is optimal solution. The first one, that is state space. So in state space, all the possible states are solutions in the problem domain. So that is called state space. The second one is start and then goal. So start means the initial point. The goal means the target point. The next one is search tree. So search tree gives a hierarchical structure for the given problem. So the next one is pathcast. So this is the numerical value measuring solution for the efficiency. So the next one is actions and then transactions. So in actions and transactions, what are all the possible moves which affects their transitions on their states changes. So the next one is optimal solution. So optimal solution is nothing but the lowest cost path from start to goal state. So there are two types. One is uninformed search, another one is informed search. So uninformed search means that is a blind search. So we don't have any additional information about the environment. So for informed search, we have additional information about the environment. That is also called as heuristic search. So there are 4 important properties in search algorithm. The first one is completeness. So completeness means which gives a guarantee for finding a solution for the given problem. So the next one is optimality. The optimality ensures the discovered solution, so which has the lowest possible pathcast. So the next one is time complexity. The computational times required to find a solutions. So the next one is space complexity. So the memory during the search execution. So these are all the 4 properties under search algorithms. So now we'll move to the types. So in types of search algorithm, there are 2 types. One is uninformed, another one is informed. So in this uninformed searches, again it is classified to birth first search, uniform cost search, depth first search, and then iterative deepening, then bidirectional search. In informed search, there are 2 types. One is best first search, another one is A-star algorithm. So the first one, breadth first search. In breadth first search, which follows first in first out. So it is called as queue, and it operates by visiting all the nodes from current depth level before moving to the next level. So in this diagram, I'll clearly picturized, that is the first node, that is the start node is A, the last node, that is the target node is G. So we have to traverse B, C, D, F, and then we will reach the goal G. So in this traverse, first the A traverse to B, then the B traverse to C. So which is the current depth level of B, then the C traverse to D, then it will traverse to E, then it will traverse to F, then it will traverse to G. Finally, G is our target goal. So we reach the target goal. It will quit the entire problem. So this is the breadth first search algorithm. So the next one is depth first search. In depth first search, it starts from the given source vertex and it explores one path as deeply as possible. When it reaches a vertex with no unvisited neighbors, it backtracks to the previous vertex to explore other unvisited paths. So it will continue until the source are visited. So in this depth first search, it will maintain stack, so which is last in first out. So in this picture, the start vertex, that is the start node is 0. The last node, that is the target node, is 6. So the from 0 it will traverse to 1. So again it will travels to 3, that is the deepest level of 1. Then it will backtracks to 1. Then it will traverse to 4. Again it will backtracks to 1. Then it will backtracks to 0. Then it will traverse to 2. Then it will traverse to 5. Then it will backtracks to 2. Then it will traverse to 6. Finally, we reaches the goal 6. So this is called depth first search. So the next one, uniform search algorithm. In uniform search algorithm, we finding the least cost path in a graph. So in this graph, the 4 is a start node, the 0 is end node. So the 4 starts from the 4 starts to find a lowest cost. So it will find the next node 3, which cost is 80. So compared to 99, it will less. So it will choose the path as 80. So it will reach as 3. Then it will move to 2. So the path cost is 97. Then it will move to 0. The path cost is 101. So the least path cost, it will reach as the goal. So this is called uniform search algorithm. So the total path cost of this diagram is 278. So which is the least cost path, the entire traversal. So the next one, iterative deepening. In iterative deepening search, which is a hybrid search strategy that combines the completeness and optimality of BFS, which is breadth first search, with the space efficiency of DFS. So it works by performing a series of depth limited, so progressively increasing the depth limit. The goal node is found. So until the goal node is found, we will reach our depth limit one by one. So like this video, the start node is 0, the end node is 6. So from start node, it will traverse to 1, then it will traverse to 3. We know that like depth first search, but here we will set the limit for this diagram. I will set the limit as 2. So my depth limit is 2. So I will traverse up to only the limit of 2. So then it will backtracks to again 1. So then it will traverse to 4. Then it will backtracks to 1. Then it will backtracks to 0. Then it will traverse to 2. Then it will traverse to 5. Then it will backtracks to 2. Then it will finally reaches the goal 6. So based on the problem, we will set the depth limit. So for suppose my goal node is not as 6 means, then it will move to, so I will just increase my depth limit to 3. So after increasing the depth limit as 3, then I will found the goal node. So this is called iterative deepening. The next one is bidirectional search. This is the last search of uninformed search. So for the bidirectional search, which is a graph search, so it is used to find the smallest path from source to goal vertex, and then it runs two simultaneously searches. The first one is forward search, which is from source node to goal node, and the second one is backward search, which is goal node to source node. So both are working as a simultaneously, it will reaches the goal. So for the bidirectional search, the application as network analysis, pathfinding, etc. The next one is heuristic search or informed search. So heuristic search or informed search, which is a additional information, that is heuristic function, which is already in a given problem. So by analyzing that heuristic function, we will able to find a solution for the problem easily. The first one, greedy best first search algorithm. So this is the search strategy that prioritizes the node estimated to be close to the goal. So it is considered as a greedy because at each step it makes the locally optimal choice based purely on a heuristic function. So first it will traverse to 1. Then by comparing the easiest way to reach the goal, it will switch to 2. So from 2 to 6, it will easily found the goal state. So then it will calculate the path cost. So the aim is to reach the goal as early as possible. So that is the main outcome of greedy first search. So the greedy first search is mainly applicable in optimization. Then it will also applicable in web search engines. The next one is A-star algorithm. So A-star algorithm evaluates and explores the nodes by combining the cost to reach the node, that is G, and the cost to get from the node to the goal, that is H. So it is the combination of G and H. So that is called the function. So which is explored the next. So the start node is 4, the end node is 0, means it will travels, and then it also maintain the history of both. One is the goal. So what are all the path we are traveling, and then the path cost. So if there is any path cost deficiency, or if there is any not defining the goal state easily, means it will backtracks to the older one, that is the backtracks to the previous one, and then it will traverse to the node. For example, from 4 to 0, first it will chooses the path that is the low cost path, that is 80. Then it will traverse to again 1. So the path cost is 99. So it will maintain both record. Then it will traverse to 3 to 1, 3 to 2. The path cost is 97. Then it will again backtrack to 1 to 0. The path cost is 2 11 11. So based on the history, it will too costly to reach the goal. So it will it will backtrack to 2 to 0. So the path cost is 101. So which is the lowest path and then easiest way to reach the goal. So this is what the A-star algorithm. So which is the optimal algorithm compared to others. The applications of this A-star algorithm is video games, network routing. So these are all the applications of A-star algorithm. So the main outcome of this unit is the students can able to understand the appropriate search algorithms for problem solving. Thank you. We will see further topics in upcoming videos.